In this lesson, we're going to examine quadratics and the families of functions that they fit into, how we can convert from one family member to another, and things that they may or may not have in common. So generally, a family of quadratics refers to groups of functions that share some of the same characteristics, just like you share some of the same characteristics of your family. Not all exactly the same, otherwise it would just be the same function, but they have similar ideas. So for example, this group here, we have an a value of 2 for all three of them. Well, the a value of 2 tells us they all are going to open up. They're all going to be the same size, same step pattern. And because neither of them have brackets, they all have the same axis of symmetry. They're all x equals 0. Obviously, they have some differences too. Right? This one has a y-intercept of -7. This one's at +4. This one's at 0. And they all have different vertexes. That's some different things. Our objective today is to figure out the equations of these. So to find a specific member of a family, we need to know a point on the equation. We're also going to be given some other information at times. For example, zeros, the vertex, axis of symmetry, things like that. If we know a point and some other information, we can always figure out the exact equation we want. The question is, what form do we need? So we have our three forms: factored form, standard form, vertex form. Reminders. Factored form would be y equals a bracket x minus s, x minus t, where s and t are the zeros. We like that form if we know our zeros. Standard form is ax squared plus bx plus c. We like this form if we know our axis is symmetry, so negative b over 2a. And vertex form, well, obviously we like that form for vertex, and its equation is a bracket x minus h squared plus k, where h and k are the vertex. Remember, when we put things into brackets, we got to change our sign. So that happens in the vertex form and in the factored form. We can convert between forms. Generally, if we want to get to standard form, we have to FOIL it, either from factored or standard. To get to factored form, we have to factor, kind of self-explanatory. And from standard to vertex, we use our negative b over 2a in the equation to get your vertex. So one nice thing about all of them is they all have the same letter at the beginning, letter A, and they have to be the same value. A is A is A. That's why we use the same letter, because they're all the same value. Okay. Okay, so let's try one. A quadratic relation of zeros of -4 and 6 passes to the point 3 and 42. Determine the equation in the three forms. So, if we're told zeros, then we're told we're starting in factored form, basically. So we'll start off with factored form. Y equals a bracket x minus s, x minus t. Oops, z. Try that again. Okay. Whenever we put our zeros in, we have to change our signs. So a -4 becomes x plus 4, and positive 6 becomes x minus 6. We have to know a point, which we do. Here's an x and a y, which allows us to solve for the a value, the stretch compress idea. So we can put in our 3 for x in both spots. Do a little bit of bed mass here. So 3 plus 4 is 7. 3 minus 6 is -3. Multiply this all together, we'll get -21a. Solve it, and a is -2. So our equation, x plus 4 and x minus 6 in factored form, is done. If we want standard form, we have to FOIL. So we're going to take our brackets, and we're going to FOIL them. X squared minus 6x plus 4x minus 24. We'll collect some like terms. And then we'll multiply that -2 through everything. Okay, and there's our standard form. So all we need is vertex form. We can do that if we find our vertex. Our vertex, the fastest way is to either use our zeros and average them, which will work perfectly fine, or -b over 2a, because we have our standard form. So we'll just do both just to show, come up to the same axis of symmetry. So -b over 2 times a will give us 1, sorry, 1, or if we use average of zeros, -4 plus 6 over 2 also comes out to 1. We can then find our y value using either of our equations. So -2 times 1 squared plus 4 times 1 plus 48. That will come out to 50, I think. Okay. Which vertex form will then be y equals a. We have a in all our different forms of -2. X minus h. H is the x part of the vertex, so -1 plus k. And k is 50. And there's our vertex form. So we have all the different forms pretty quickly, actually, by recognizing we're given information about zeros and a point. Let's try the next one. Part of the graph of a quadratic function f is given in the diagram below. On this graph, one of the x-intercepts is the point 50. The x-squared of the maximum point is 3. The function f is given by this equation. Find the values of b and c. So we have to interpret some things. It tells us the x-coordinate of the maximum point is 3. In other words, there's 3. 3 and something. We don't know the something. It also tells us the x-intercept is the point 50. Well, that has to be to the right of it. That's got to be 5. The nice thing about quadratics is they have symmetry to them. So the distance from here has to be the same distance here. We know this is 2 units from 3 to 5. So this also has to be 2 units. 3 to 1. And if I know 2 zeros, well, that makes my life easier because I can use my factored form if I wanted to. Okay. Nothing wrong with that. But to use factored form to solve for a, I'd have to know a point. I don't really know a point yet. Plus, I also have to look at this equation. It's in standard form. So what can I use in standard form? Next thing with standard form is we have this equation, -b over 2a. The axis is symmetry. Well, we know that because we were told 3 is the x value. Do we know b? No, we're not trying to find that, right? But we do know a. A is -1. It's right here. So I have this equation, -b over -2, or in other words, 3 is b over 2. If I cross multiply, I get 6 is b. Well, that's kind of handy. Now I have most of the equation. I have -x squared plus 6x plus c. In order to get c, I need to know a point on this graph. We actually know 2 of them now. We know both zeros. We can use either one. Okay, 5, 0, or 1, 0 are points. So I can use the 5, 0, 1. Y is 0. Oops, I should have a squared on it. Okay, x is 5. X is 5 again. I want to find c. Again, I should have the squared on there, sorry. So we're going to get -25 plus 30 plus c, or 5 plus c. C is -5. And I've solved for a and b using a little bit of ideas about symmetry, -b over 2a, and zeros. We'll try another one. All today's all just examples. So graph of a function is given by the standard form. It intersects the y-axis at point A, 0, 5, and has a vertex at 4, 13. Write down the value of c. Well, c is our y-intercept. That's the whole idea of when they put zeros in for x's, you're left with your y-intercept. So we know that c has to be 5, because we're told the y-intercept is 5. By using the coordinates of vertex b or otherwise, write down 2 equations in a and b. So what they're asking for here is, can you give me an equation that has an a and a b in it? And in fact, can you give me 2 equations? So what do we know? We know that b is made up of a point. We also know that's the vertex. So one simple equation could be 13 equals a times x squared plus b times x plus c. C we just figured was 5, right? And we can simplify this equation. We got 16a plus 4b plus 5. Or in other words, 8 16a plus 4b. There's one equation. That will totally work. The second equation, you have to think a little bit more. And the key here is that they're giving us an equation in standard form. Standard form usually hints at, we can use this. And notice it has an a and a b in it. The axis of symmetry value is 4. That's the x-coordinate of the vertex. We don't know b, we don't know a, but we have an equation now that's got an a and a b in it, which is what we were asked for. If we cross multiply just to make things a little bit easier, we'll get 8a equals negative b, or if you want to, 8a plus b equals 0. Now we got ourselves two equations that have a and b in them. Okay, part C, find the actual values of these things. Well, we can do that. If we have two equations, we can use elimination. So I'm going to take my first equation, this one here. 16a plus 4b equals 8. I'm going to take the second equation and I'm going to double it. So I got 16a plus 2b equals 0. And then notice my a's are the same. They have the same sign. They're both positive 16s. So I'm going to subtract them. 16a minus 16a is gone. 4b minus 2b is 2b. 8 minus 0 is 8. So b is 4. And once I know b, I can go back to one of my original equations. This one right here. It's nice and easy to work with. I can fill in the b that we know. It's 4. So I'll get 8a equals negative 4. Or in other words, a is negative 1/2. Okay, and then we've solved that. That wasn't too bad. All right, one more. The diagram below shows part of a graph. They give us some of the information. The line x equals 2 is the axis of symmetry. M and n are points on the curve as shown. Find the value of a. So again, they're giving us a hint. It's in standard form. Standard form means negative b over 2a, probably useful. We know the axis of symmetry is 2. We know b is 4, so negative b will be negative 4 over 2a. Cross multiply and solve. And we got a. We find the coordinates of m and n. Now m is really nice because m is our y-intercept right here. So it's 0 and c. There it is right there. So m is just 0, negative 3. No math required for that one. But to figure out n, we got to recognize that n is our vertex. We can find vertex using our axis of symmetry, which we know, 2, and figure out the point that goes with it. To figure out the point that goes with it, we need our equation. Our equation is a, we solved that, negative 1x squared plus 4x minus 3. And we're going to put in x as 2, because that's our axis of symmetry. We're going to do our little bit of math here. So we'll get negative 4 plus 8 minus 3, and that comes out to 1. So n is the point 2 and 1. Okay, so those are some families of functions. We had to figure out specific members of the family by doing a little bit of problem solving, being in different forms, being comfortable moving from one form to the other. Now, those are one way of solving most of those questions. There are other ways. You don't have to use axis of symmetry. You can maybe use zeros or the vertex. You can use different forms in different ways. It's up to you to try and figure out which one to do. So some questions to try, and then we'll move on to the next lesson.